Okay folks, Chapter 5 of C3 AQA Chemistry GCSE. This is a revision video with exam questions at the end. For this topic you need to know about alcohols, carboxylic acids and esters. So let's look first of all at alcohols, and let's start with some uses of alcohols. So first of all, obviously, ethanol is the main chemical that's found in alcoholic drinks, so that's one use. Also alcohols, you should know this from C1 actually. Ethanol is made for fuels, to be used as a fuel, to burn. It releases a lot of energy when it's burnt in oxygen. And that ethanol, one way of making that ethanol is from a plant, sugar cane actually to be precise, and so that's why I've got this picture of a plant here. That's one way of making ethanol, but you can also make it from an alkene, ethene. But yeah, like I say, that's from C1, but it's worth just reminding yourself that this sort of thing could crop up even in the C3 paper. Next use, final use that's worth knowing, is nicely illustrated in this little cartoon. So you've got alcohol here versus spray cleaner, and it says I'm good at cleaning mirrors, removing stains, removing stickiness. The reason for that is that alcohol is a really good solvent. And remember, by solvent, we mean it dissolves other chemicals really easily. That's why it removes stains really easily, because it dissolves the stain, making it, a really good solvent. The other use that's worth noting is that alcohol, you probably know this without thinking about it, is used in antibacterial, like hand san. It's really good at killing bacteria. So 4 really useful uses there for alcohol. I thought this was worth mentioning to you. If you're not using it already, you really should download the specification, GCSE specification. So this is the latest version that I've got here for you, and this breaks down exactly what you need to know about alcohols, carboxylic acids and esters. And actually when you see it listed here like this, it's really not too bad at all. So if we take each point in turn. So let's start with alcohols. So it says here at the top of the page, alcohols contain the functional group OH. Methanol, ethanol and propanol are the first 3 members of the homologous series of alcohols. So we're not expecting you to know all the alcohols and all their names, but we are expecting you to be able to probably name these first 3, methanol, ethanol and propanol. So I want you to pause the video now at this point and grab a piece of paper. Let's see if you can remember how to draw methanol, ethanol and propanol. Okay, so the first thing to remember is that all of the alcohols will have to have the OH group in them. That's what makes an alcohol an alcohol. So with methanol, I've not left myself enough room, bad drawing. But methanol here, 1 carbon, 3 hydrogens in the OH group. Ethanol, because it's eth, it's got 2 carbons. Oh dear. Draw yours a lot better in the exam. Leave yourself enough room. 2 carbons. Propanol, because it's prop, it's 3 carbons. We've got, each carbon must have 4 bonds, remember. So have a look at yours. How many did you get right? Probably yours look loads better than mine, so well done. Okay, next thing to have a look at is, where are we? well, it's worth just reading this additional guidance here. It says candidates should be able to recognise the alcohols from their names and formula, but do not need to know the names of individual alcohols other than methanol, ethanol and propanol. Okay, let's have a look at B. So methanol, ethanol and propanol. This section here is specifically looking at how these alcohols react in different situations. So we're looking at dissolving, how they react with sodium, how they burn in air, and how they're used as fuels, solvents, and in alcoholic drinks, which we've talked about already. So let's look at these three. So dissolve in water, well, we saw that, you've seen that. If you add an alcohol to water, you could do this home with permission. If you put it in a test tube, put your alcohol in, you top it up with some water, you give it a good shake, so shake them up, and you will see that your test tube will contain both chemicals, alcohol and the water, but you won't have any layers. You'll have one solution dissolved within the other. Okay, so what if I pop some sodium in? So some sodium metal, really reactive metal. You've seen it probably, hopefully, reacting with water. If we drop it into our alcohol, we will see lots of bubbles, lots of fizzing, and that is because hydrogen gas is produced. Now, you should know how to test for that gas. So if you're unsure as to what gas you are making, you would source a flame. You'd hold the flame just above where the gas is being produced, and if you hear the classic pop, then you know that you've got hydrogen gas. Okay, burning in air. Now, it's worth just reading this additional guidance here actually. It says candidates are not expected to write balanced chemical equations for the reactions of alcohols other than the combustion reactions. So, quite important here to note that they could see an opportunity to pop in an equation writing task, and that it might be that you've got to write the full equation yourself and then balance it. It might be that they give you the equation and then you've got to balance it. We don't know, so we're going to do both now. So I'm going to do this at a funny angle so I can fit it onto the screen. So we've got, if we have methanol, which is CH3OH, we need to be able to produce a chemical equation. So I'd like you to pause the video now, grab your piece of paper and see if you can generate don't worry about balancing yet, just a chemical symbol equation for burning methanol in air, please. Okay, so the gas we're after in air to burn anything is oxygen. So we're going to write plus O2, because oxygen exists as O2. Goes to, and then we get this gas, these gases when we burn any fuel, CO2 plus H2O, just fitted it on there. So now we need to balance it. Now this one takes a bit of jigging around actually. So pause the video now, give yourself a couple of minutes to see if you can balance this equation, and then we'll go through the answer. Okay, so this one you should have ended up with a big 2 here, a 3 here, a 2 here, and a 4 here. So just to check that everything's balanced, because we all make mistakes. We've got 2 carbons here, and we've got 2 over here, so carbons are balanced. Hydrogens, we've got 3 and 4 within the molecule, but we've got 2 lots of that molecule, so that's 8 oxygens altogether. And over here we've got 2 within the water molecule, but we've got 4 lots of water molecules, so that's 8, so that's looking good. Oxygens, we've got 2 within the O2 molecule, and we've got 3 O2 molecules, so that's 6 oxygen atoms. And don't forget the 2 over here as well, so that's 8 oxygens altogether. And over here we've got 2 within carbon dioxide, 2 lots of those 2, so that's 4. And then we've got 4 oxygens within these water molecules, so that's 8 altogether, so everything's balanced. So that kind of sums up everything you need to know about those 3 reactions. The final reaction that you need to know about is that of ethanol, and the fact that it can be oxidised to make ethanoic acid. And it says here by either oxidising agents or microbial action. So it's just worth noting that actually, that rather than giving you an oxidising agent, so we use dichromate in the lesson, they could talk about microbes being involved in this reaction too, but either way ethanol will change into ethanoic acid, and ethanoic acid, says over here as well, is the main constituent of vinegar, but as a solution, so it'll be dissolved in some water to make vinegar. So that's alcohols in a nutshell. Now we move on to ethanoic acid as a carboxylic acid. So it's worth maybe testing yourself, pausing the video now to see if you can draw ethanoic acid. Ethanoic acid, of course, starts with Eth, so we know it's 2 carbons still. Each carbon must have 4 bonds, remember, and because it's a carboxylic acid, it will have this functional group on it, so this Q group, that's how we spot them, and they all end in oic acid. The start of the name is dictated by how many carbons, so you could have methanoic acid if you've got 1 carbon, propanoic acid if you've got 3 carbons. Again, a bit like with the alcohols, actually, it does say over here, should be able to recognise carboxylic acids from their names or formula, but not need to know the names of individual carboxylic acids other than methanoic, ethanoic, propanoic. And as before, candidates are not expected to write balanced equations for the reactions of carboxylic acids. So the ones you need to know about are dissolving in water, reacting with carbonates, reacting with alcohols to make esters, and then a little bit more detail about why they have certain acidic properties. So let's look at dissolving. This is exactly the same as alcohols. If you have a test tube and you put carboxylic acid in with your water, so we've got our carboxylic acid in there, water in there, shake them up, and you will find that, just trying to show that these mix, you'll have 1 chemical mixed up, no layers, because they dissolve very, very nicely within one another. Reacting with carbonates, so grab a new test tube, you'd put your carboxylic acid in, and it is an acid, don't forget. It doesn't matter what sort of acid, it's an acid. You'd add your carbonate powder in, and you would see loads and loads, so your carbonate would probably sink down here, and you'd see loads and loads of bubbles. Now this time it's not hydrogen gas, it is in fact, the clue's in the name, carbonate makes carbon dioxide, so loads of CO2 will be produced. And though it's not mentioned here, it's worth just reminding yourself about how you test for carbon dioxide. And you should remember, again from C1 actually, that you'd use lime water, so you'd take the gas, you'd put it into some lime water, and if the lime water goes cloudy, then you know you've got CO2 present. Okay, reaction with alcohols in the presence of an acid to produce esters. So, let's imagine we've got ethanol and ethanoic acid. These two things would react together to make an ester called ethyl ethanoate. And the ethyl part comes from the alcohol, and the ethanoate part comes from the ethanoic acid, the carboxylic acid. Okay, last bit on this page. Notice this is higher tier only, so this definitely applies to you if you're sitting higher tier. It says carboxylic acids do not ionise completely when dissolved in water, and so are weak acids. And then aqueous solutions of weak acids have a higher pH value, so we mean closer to 7, than aqueous solutions of strong acids. So this is really easily explained. Let's take ethanoic acid, and let's take hydrochloric acid, both acidic, will both have pHs below 7 because they're both acids. And the reason they are both acids, as with any acid, is that when they are in solution, so if we pop AQ here, it reminds us that means in solution, they will both have hydrogen ions present, both of them. The reason hydrochloric acid here is considered a strong acid is that it is able to ionise completely, fully, when put into solution, i.e. these hydrogen ions here are able to dissociate fully from the hydrogen chloride as a compound. So you end up actually, when in solution, it leads to hydrogen ions and chloride ions. So they fully dissociate. We say they ionise completely. That sentence is down here. So completely ionise, meaning that there are lots of hydrogen ions in solution, and that's what gives it the really low pH. So you come out for hydrochloric acid, you'd be looking at probably pH 1. Whereas with ethanoic acid here, it does not fully ionise, so you end up with these ions, but we say that it only partially ionises, or it does not ionise completely, and that sentence is written down here in the specification, does not completely ionise. And so when it is in solution, it has a higher pH than 1. You normally expect ethanoic acid to come out at about pH 3. So vinegar will come out at about pH 3. And that's because the compound, the ethanoic acid, has only partially ionised. Okay, final topic to look at is esters. Worth noting here, you only need to know about ethyl ethanoate, really, in terms of naming, but it's worth being able to spot this functional group here. And also to say that esters are used for flavourings and perfumes because they've often got quite sweet smells, and it's not noted here in the specification, but a question that does sometimes come up is which catalyst is used to produce the ester, and the ester reaction takes place using an acid catalyst. You know that catalysts speed up reactions, and so making an ester involves an acid catalyst. So esters have the functional group COO. So what does that look like drawn out? Well, it looks a bit like this. So the COO group. In fact, if we let's draw ethyl ethanoate. So here's the ethyl part, 2 carbons here. And then the ethanoate part. So you've got ethyl, 2 carbons, ethanoate, 2 carbons. And this part here has come from the alcohol, and this part here has come from the carboxylic acid. So this has been made up of, or from, ethanol and ethanoic acid. And it is called ethyl ethanoate. And so in the exam, what would you need to do? Well, you'd probably need to be able to identify the functional group, and the functional group is just here. That's the functional group, the COO group. Self-assessment time. You need to pause the video, have a go at the questions, then unpause the video, and I'll talk you through the correct answers. So question 5A, these are all from recent exam questions, 2015 paper, this one. It says here, the question is about organic compounds. Ethanol is an alcohol. One use of ethanol is alcoholic drinks. Give 2 other uses. So if you think right back to the beginning of this video, you should remember you could have had solvent, we could have had fuel, and we could have had antibacterial. Any 2 of those for 2 marks. Which gas is produced when sodium reacts with ethanol? Well, it's not a carbonate, we're talking about sodium. So there's only one possible gas, metal plus ethanol gives us hydrogen gas, and lots of it. And you could have a question there to extend to talk about the POP test and how you would test for hydrogen, but it's not here. Okay, ethanoic acid can be produced from ethanol. What type of reaction produces ethanoic acid from ethanol? So this is our oxidation reaction. So next one's a classic question. Complete the displayed structure of ethanoic acid. So it's got to have that COO group. It's got to have 2 carbons. So no more carbons to add on. But we do need to add the oxygen and the OH group. So this is the functional group of a carboxylic acid. Solutions of ethanoic acid and hydrochloric acid with the same concentration have different pH values. Explain why the solution of ethanoic acid has a higher pH than the solution of hydrochloric acid. So ethanoic acid, remember, is about pH 3, we said. Hydrochloric acid, pH 1. So ethanoic acid has a higher pH because it's a weak acid which does not fully or completely ionize. Okay, part D, ethanol and ethanoic acid react in the presence of a catalyst to form an ester. Name the ester. Well, there's only one ester that we need to ever be able to name, which is ethyl ethanoate. D part 2, what type of chemical is used as a catalyst in this reaction? So D part 2, what type of chemical is used as a catalyst? I mentioned it in when we talked about the specification. It's an acid catalyst. Esters are used in perfumes because they smell pleasant and are volatile. What does volatile mean? So you could put one of two things here. We could say that it has a low boiling point, and it evaporates easily / quickly. But the reason it does evaporate easily is because it has a low boiling point. So here's the structure of an alcohol. It says draw a circle around the functional group in the structure of the alcohol. Well, that's here. What is the chemical name of this alcohol? Well, it's 2 carbons, it's got the alcohol group, so it's ethanol. Alcohols are used as fuels. A student plans to carry out an experiment to find the energy released per gram of an alcohol when burned. The student uses the apparatus shown in figure 3. Suggest 2 ways that this apparatus could be improved to obtain accurate results. Well, accurate means to get an answer as close to the true value as possible. So a few things you might do to make sure that the experiment was as accurate as possible. You might add a lid. The heat, the energy that's released from the alcohol burner really should be going into the water and not being lost, so you'd add a lid maybe. And you possibly would think about insulating the beaker. Because you want all the energy from the alcohol to go to the water to give you a better idea of how much energy is released, you might want to use a metal container, because that way the heat gets conducted far more quickly than with a glass beaker straight into that water. So when an acid reacts with scale, a gas is produced. Now, this question was actually within another question about water, but because scale has a carbonate in it, we can answer this question using our organic chemistry knowledge. Because it's a carbonate and it's added to acid, we release CO2. But be careful, it said what is the name of the gas? So this gas is carbon dioxide. Ethanoic acid is used to remove scale. Complete the displayed structure of ethanoic acid. Okay, so we've just had this question, so you can see that the questions often get repeated. That's worth noting. But here it is again, our AQA group. There's the functional group. You don't need to do that as part of this question, it's just good practice to see it again during revision. So a student compared the rates at which ethanoic acid and hydrochloric acid react with scale. Both acids had the same concentration. The student found that hydrochloric acid reacted faster than ethanoic acid with scale. Explain why hydrochloric acid reacts faster than ethanoic acid. Well, we have just answered this question. But this time we can talk about hydrochloric acid as the subject. So we can say hydrochloric acid is a strong acid. And remember, strong acid means it will ionize completely. And remember, ionizing completely means it will have more H+ ions present. Okay, Hydrochloric acid should not be used to dissolve scale in kettles. Explain why. Well, the hydrochloric acid compared to ethanoic acid is a corrosive acid. So people often use vinegar to clean their kettles, but we don't advise using hydrochloric acid because it's a strong acid and it is corrosive. Okay, this question is about ethanol. Look, again, same question coming up. Complete the displayed formula of ethanol. So 2 carbons and the alcohol group. Next question. Wine left in a glass for several days turns sour. The sour taste is caused by ethanoic acid. Complete the sentences. The ethanoic acid is produced from a reaction between ethanol and oxygen. And this is oxidation. Remember, this is about adding on oxygen to make ethanoic acid. And because this has just been left out for several days, it says here, rather than us doing this as a lab oxidation using oxidation reagents, this has been done, if you remember the specification, it said be aware of microbial oxidation. So microbes have been involved in this process. Final set of questions. Propyl ethanoate, a fragrance, can be produced by reacting ethanoic acid with alcohol. Propyl ethanoate is a member of a series of organic compounds. The members of the series all have the same functional group. The displayed formula of propyl ethanoate is given here. Draw a ring around the functional group for this series on the displayed structure. So here we go. Because don't forget, this is our ester group. And just here, name the series of compounds with this functional group. These are esters. The alcohol used to make propyl ethanoate has the formula here. Name the alcohol. Well, there are only 3 alcohols that we need to know about. This has got 3 carbons in it. And it gave the ester, the propyl part of its name. So this alcohol is propanol. Questions? It's the end of the video. I hope you've considered now that the specification use is really useful, so I definitely suggest downloading the specification. I hope you've also just seen, by going through those exam questions, how many times they are repeated. So the types of question that are going to come up, probably you'll have something that involves you identifying one of these functional groups or drawing one of the organic compounds with one of those functional groups in. And I hope you've also seen how these questions can fit in quite easily within other topics within C3, for example the water topic, talking about scale in kettles and so on. Thanks for watching. Please feel free to leave any comments below and I'll get back to you. Thanks.